Welcome, everyone. Today we're going to be converting the following to polar form in radians. So let's dive in. Okay, so what does polar form look like in the first place? Polar form looks like r theta. So we need to convert this, which is in xy form, to r comma theta form, where r is the radius or the magnitude from the origin to whatever point we have in terms of x and y. And the theta is the angle, also sometimes called the argument as well. Okay, so how can we find the radius first off? Well, we can use this equation over here, that x squared plus y squared is equal to r squared, and then we can take the square root of both sides to solve for what r is, to get the first part of our polar coordinates. So for this one, we're going to have that r squared is equal to 3 squared plus negative 7 squared. That means r squared is equal to 9 plus 49. That means r is equal to the square root of 58 in this case. And so there we go. Okay, next thing we need to do is we need to figure out the argument or the angle theta. And so to do that, notice that x is equal to r cos theta and y is equal to sine theta. And so what we can actually do here is we can say, well, that means y over x is equal to r sine theta over r cos theta. The r's cancel out, and then sine over cosine, recall that that's just tan. Therefore, tan theta is equal to y over x, meaning that the inverse, that theta itself is equal to tan inverse of y over x. So this is actually the key formula that we want to use, this last formula here, but I did want to briefly also discuss like how we derive this formula and how we actually come to that formula using formulas that you're probably more familiar with, like r cos theta and r sine theta formulas. Okay, so in this case here, we have that theta is going to be equal to inverse tan of y over x, which is negative 7 over 3. And if we type that into our calculator, and make sure your calculator is in radian mode, otherwise they will give you the wrong answer, we're going to get negative 1.17 radians approximately. So therefore, we ended up with the r value being root 58 and the theta value being negative 1.17. So therefore, the polar coordinates are root 58 for r, comma, negative 1.17 for the argument. And there we go. All right, and let's do one more example. All right, so first let's find the r value for the second one. So how do we find the r value? Well, r is equal to the square root of x squared plus y squared, meaning r is equal to the square root of 1 squared plus negative 5 squared, which is equal to 1 plus 25, which is equal to root 26. So the r value here is 26. Then for the next one, we know that theta is equal to inverse tan of y over x, which is negative 5 over 1 in this case, or just negative 5 is fine as well. And then that is going to be equal to, let's see in the calculator here what that will be. That is going to be negative 1.37 radians approximately. So therefore, the polar coordinates, the final answer here with the polar coordinates, would be root 26, comma, negative 1.37. And there we go. As always, if you have any questions, please leave those down in the comment section, and we'll see you for the next one.